We want to find the zeros of f, and the way we're going to find the zeros is we're going to set f equal to 0. Notice that the fundamental theorem of algebra would tell us that we should end up with 3 zeros. So to get started, let's list the possible rational roots. So the possible rational roots are going to be of the form p over q, where p is going to be a factor of -3. So that would be plus or minus 1 plus or minus 3. And q will be a factor of 4, and those factors are plus or minus 1, plus or minus 2, plus or minus 4. So our possible rational roots are 1 over 1, which is 1, 1 over 2, which is a half, 1 over 4, which is a fourth, 3 over 1, which is 3, 3 over 2, which is 3 halves, and 3 over 4, which is 3/4. So if this function has any rational zeros, they are going to be 1 or -1, 1 half, -1 half, 1/4, -1/4, 3 or -3, 3 halves or -3 halves, 3/4 or -3/4. So to find which ones work, we're going to have to synthetically divide. So we have 4, 8, 1, -3, and we start going down our list till we find one that works. I'm going to actually start with -1. Bring my 4 straight down. -1 times 4 is -4. 8 plus -4 is 4. -1 times 4 is -4. 1 plus -4 is -3. -1 times -3 is +3, which gives me a 0. So yes, x plus 1 is a factor, and x equals -1 is a 0. So what's the other factor? Well, the other factor are the leftover numbers, which would stand for 4x squared plus 4x minus 3. So I'm going to take 4x squared plus 4x minus 3 and try to factor it. Note that if they don't factor, you can always use the quadratic formula. But I think this one does factor into 2x plus 3 times 2x minus 1. So if I set each of those factors equal to 0, 2x plus 3 equals 0, means that 2x equals -3, and x is equal to -3 halves. 2x minus 1 equals 0, gives us that 2x is equal to 1, and x is equal to 1 half. So 1 half, -3 halves, and -1 are the 3 zeros of this polynomial.